Okay, let's talk about example 2. Now, the reason I'm going to do 2 and 3 together is they're both examples of elimination, which is a slightly different method. Basically, in substitution, you want to solve one of the equations for x or y and use what you get to plug back into the first one or the second one, depending on which one you solve. Here, we want to do something completely different. We want to try and cancel out one of the variables by adding the two equations together. In order to do that, what I want to focus on is this. You want one of the variables, right? It doesn't matter which one, can be x or it can be y, to have the same coefficient out in front. However, one of them be positive and one of them be negative. Okay, that's what we're looking for. This problem, that's very nice. It's already kind of done for us, right? It's just there, which means all we really need to do is add the two equations together. So that's what we're going to do. We're going to add these two equations together. We're going to add straight up and down. Okay, we're going to add 2x and x, negative 3y and 3y, and negative 11 and 11. Okay, and since these things are equal, left and right side, we're not changing the value, right? We're just doing the same thing on both sides. All right, so what does that work out to? 2x plus x is 3x. Negative 3y plus 3y is 0, right? It's gone. So those eliminate, hence the name elimination. And over here, we got negative 11 plus 11. Interestingly enough, this goes away too. We end up with 0. Okay, that will not always happen. Okay, it's not a given. It's not a guarantee by any means. All right, next, we would want to continue solving this for x. So I would divide by 3. And I get x equals 0. So that's my x value. Now, to figure out what y is, I want to take that x of 0 and plug it back into one of the original equations. It does not matter which one. Here's what I'm going to suggest, and it's my recommendation. I always look for the one that has the least negative values in it, right? So the bottom one to me doesn't really have any negatives. So that should be the easier one to plug it into. So when I plug that back in, I'm going to go 0 plus 3y equals 11. Well, that's nothing, right? So that's not even necessary. So I have 3y equals 11. Divide by 3, and we get y equals 11 thirds. Okay? There we go. Now, that means that's my solution. That's what I got. That means that this statement right here should work for both of them. 0, 11 thirds. I'm going to check that. So 2 times 0 minus 3 times 11 thirds. Right? That should equal negative 11. Okay, 2 times 0, that's gone. So I have negative 3 over 1 times 11 over 3 equals negative 11. Those 3's cancel. I end up with negative 11 equals negative 11. Perfect. Check the second one. 0 plus 3 times 11 over 3 equals 11. Again, 3 over 1, 3's cancel. 0 plus 11 over 1 is 11, and that also checks out. So it works for both, therefore, that is our solution. Okay, so that is our answer. Now, sometimes what you'll find is that you have to solve it by not only using elimination, but also using multiplication. Okay, so that can make things a little bit trickier. What we want to do is we want to have both of them be able to cancel out, right? Have one of the variables be able to cancel out in both the equations. Right now, that's not possible. Okay, right now that can't happen because if I were to add this together like it is, x plus negative 2x, that's not going to work, right? So again, think back to what you want to happen. I want to have the same coefficient but have opposite signs. So since this is a negative 2, right? If I think about that being a negative 2, that means in front of this x up here, I really want it to be a positive 2. Okay? Or, since this is a positive 6, I really want this to be a negative 6 in front of the y. It can be either variable that you try to cancel. It's completely up to you. So if I want this to become a 2, what would I need to multiply this whole equation by? If you multiply both sides by a positive 2, you'll get what you want. So let's do that. And I'm going to always, the way I do it is I just bring it down. okay, below what's going on, and kind of just rewrite it. So what I now have is 2x minus 6y, because that's distributed property, and I'm actually distributing all the way through on the other side as well. You can think about it as multiplying that 2 on both sides. You can do it as two separate things or just one big one. It's completely up to you. And now I'm going to bring down the other guy just the way he was. Be careful when you're rewriting these. Don't make careless mistakes and swap signs or something by accident. All right. Now what you should see here is that this is going to work out to kind of an interesting solution. All right. So 2x minus 2x is gone. So that's 0. Negative 6y plus 6y, also 0. And we've got 10 plus 4, which is 14. So I end up with 0 equals 14. If I end up with 0 equals 14, then what can I possibly do with that? Well, 0 plus 14, or 0 equals 14, is not a solution, right? That's not a true statement. Okay, so that's one of our special cases where it's either infinitely many solutions or no solution. When it's not the same on both sides, when it's not 2 equals 2, or 14 equals 14, or 0 equals 0, right? When it's not the same number on the left and right side, that means that there's no solution to this problem. And I want to go ahead and mention what that looks like as a graph, or what that looks like graphically, because we've already said it a couple of times in class. That means that these two lines are parallel. Okay? Two lines are parallel. This is the answer. That's the answer to the question. There's no solution to this system of equations. But graphically, what does it look like? It's two lines that are parallel to each other. Okay? If it was infinitely many, it would actually be the same line on top of itself. Okay? All right. Good luck with the rest of the practice on these. If you have any questions, let me know.